Whenever you see a product is just amazing, or one that's a total train wreck, there's always a story behind it. And it's usually not what you think. It's not about some lone genius inventor or one single dumb mistake. No, the real story is hidden. It's in the unseen frameworks, the systems, the ethics, the thousands of little decisions that make or break a product. And today, we're going to pull back the curtain on those frameworks.
So, why do great products fail? I mean, this is the big one, right? This is the question that haunts every engineer, every project manager. You can have the smartest people, the coolest tech, a bottomless budget, and still everything can just completely fall apart. The answer? Well, it's not in the blueprints. It's not in the code. It's buried deep inside the systems that brought it to life in the first place. All right, so here's how we're going to tackle this. First, we'll look at the blueprint for failure. Then, we'll talk about building an ethical compass and how the system itself can be the solution. After that, we'll get into what quality actually means with the 8 dimensions and how to achieve near perfection with Six Sigma. And we'll wrap it all up by looking at what it means to be a next-gen engineer today.
Okay, let's dive into the tough stuff, why things go wrong. It's so easy to blame a single broken part or a sloppy bit of code, but the truth? The biggest failures, they're almost never just technical. They're human, they're systemic. The real problems start way, way before anything actually breaks.
So, what creates the kind of environment where bad decisions happen? Well, research shows that usually boils down to 3 things. First up, the resource crunch. This is all about pressure. Not enough time, not enough money, which leads to people cutting corners. Then there's opportunity. This is when the system kind of looks the other way, maybe focusing on short-term wins and ignoring the long-term consequences. And finally, attitude. We're talking low morale, a culture where nobody speaks up, where it's easier to hide a problem than to fix it. Sound familiar?
All right. So if the problems are human, the solutions have to be human too. That's where we get to engineering's moral compass. And look, this isn't some boring, abstract concept from a textbook. This is the real, practical foundation that stops things from going wrong in the first place.
So what is engineering ethics really? It's the framework of values that's supposed to guide the whole profession. It's about figuring out the right thing to do and being able to justify it. The most important thing to get here is that this is proactive, not reactive. It's not just about cleaning up messes. It's about making sure those messes don't happen, because the #1 job is to protect public safety, health, and welfare. It's literally the first line of defense.
But how do you actually make these tough calls? Well, there are different ways to think about it. Take these 2 theories. On one hand, you've got this ethics of rules approach. Think of it like a judge. It's all about abstract principles, justice, and following the rules in the right order. It's very logical. On the other hand, you have the ethics of care. This is more about context and relationships. It asks, how can we solve this without breaking trust and hurting people? The best engineers know how to use both. Sometimes you need the strict rule book, and sometimes you need to focus on the human side of the equation.
Okay, so having a moral compass is absolutely critical. But let's be real, good intentions alone won't get a space shuttle into orbit. You need a map. You need a system. A really robust system that bakes quality right into the process from the very beginning. One person can't do it all. The system has to be the solution.
And this is what that map looks like in practice. Now, don't squint trying to read all the tiny text, that's not the point. Just look at the 2 columns. On the left, you have your standard systems engineering stuff. On the right, you have the requirements for ISO 9001, which is basically the gold standard for quality management worldwide. See how neatly they line up? That's the whole point. This shows that a good quality system isn't just a bunch of paperwork. It's the actual practical framework that ensures great engineering doesn't just happen by accident, but happens every single time.
So we have our compass, we have our map, but where are we trying to go? What's the destination? What is quality, anyway? It's a trickier question than you'd think. I mean, what makes a quality car? Is it the one that's super fast, or the one that will run for 300,000 miles without a problem? We need to define what good actually looks like.
And that's where this framework, Garvin's 8 dimensions of quality, comes in super handy. It helps us break down that vague idea of quality into things we can actually talk about and measure. You've got the obvious stuff like performance and features, but then you've got reliability. Does it keep working? Conformance, was it built to spec? Durability, how tough is it? Even things like serviceability, how easy is it to fix? Aesthetics, and what people think about the product. It's perceived quality. The point is, world-class products aren't just good at one of these things, they're great at several.
Okay, now we get to the really powerful tools. We've defined our destination, that multidimensional quality, and we have our system to guide us. But how do we actually execute? How do we get insanely close to perfection? Well, for some of the best companies on the planet, the answer is a methodology called Six Sigma.
This number right here, this is what Six Sigma is all about, 3.4. But 3.4 what? That's 3.4 defects for every million chances you have to make one. Let that sink in, not per 100, not per 1,000, per million. That's 99.99966% perfect. It is an unbelievably high standard, and you can only even dream of getting there with a ruthless focus on data.
So how do you do it? The engine behind Six Sigma is a 5-step process called DMAC. It's pretty logical, actually. You define what you're trying to fix. You measure how bad the problem is right now. You analyze all that data to find the real root cause. Then you improve the process to fix it. And here's the key, you control it. You put systems in place to make sure the problem never comes back. It's a constant, powerful cycle of improvement.
And one of the classic tools you'll use, especially in that analyze step, is this, the cause and effect diagram. People call it a fishbone diagram, and you can see why. The problem you're trying to solve is the head of the fish, and all the bones are different categories of potential causes, things like the people, the methods, the materials, whatever. What this does is force you to think about everything that could possibly be causing the issue, so you don't just latch onto the first, most obvious answer. It's all about digging down to find the true root cause.
So let's pull all these threads together. We've talked about having a moral compass, about building robust systems, about defining quality in a real way, and about the tools to make it all happen. When you combine all of that, what you get is a totally new picture of what a modern engineer really is.
It's really about having a holistic mindset. Being a great engineer today isn't just about being the best at CAD or crunching numbers. It's about blending all of this together. It's having that strong ethical core, being a master of complex systems, and having that unstoppable drive for quality. It's about seeing yourself as more than just a problem solver. You're a guardian of public safety, a force for good, and someone who truly understands the systems that make our world work.
So I'll leave you with this question to think about. The next time you pick up a product that's just perfectly designed, or you deal with something that's incredibly frustrating and fails you, try to see past the obvious. Ask yourself, what are the hidden frameworks I can't see? What were the ethical calls, the system designs, the quality decisions that led to this exact moment? Because that's where you'll find the real story.